Okay, this is the last section of the chapter. And the plan is we're going to do 8-7 today. I'm going to give you extra problems on 8-7 for tomorrow in class. And then we'll do a quiz on 8-5, 6, and 7. I think that's right. And then Thursday, you guys can work on your chapter reviews in class. Friday, I'm going to go through those. And then Monday will be your chapter test on chapter 8. That's the plan. Okay, so this last section is the only section in this chapter that does not involve right triangles. And what we're going to do is learn how to use these two laws, law of sines and law of cosines, to actually solve triangles that are not right triangles. Up until now, we've been solving triangles that are right triangles. Okay? The first thing that's important, so everybody agreed, not a right triangle. Okay. Always label your triangle with the side lengths that are opposite the vertex, right? We've worked on that, but keep doing that practice because it's really important with this law, these two laws. Okay, law of sines. And I'm going to write it in terms of this triangle, and then I'm going to do an example. And it's on the wall, okay, if you need the formula for both law of sines and law of cosines. Law of sines says sine of angle A over side A, that ratio is equal to the sine of angle B over side B is equal to the sine of angle C over side C. Each one of these ratios is equal. Okay, so if I know this angle is, I'm just going to make some up here, and I know this angle is 60, and let's say this side length is 5. I can find this angle, right, just by taking 180 minus those two. I can find this side length by setting up that ratio. Sine of 60 over the side length opposite, 5, equals sine of 35, which is sine B, over side B. I can set those ratios up to solve for one of the sides. Okay, and because I could solve for this, 95, that's 85, right? I could also set up sine 60 over 5 equals sine 85 over side C. Just using these ratios. Okay, so how would I solve this first equation? What would I do to solve this? This first equation. Cross multiply. Yep. So it would be 5 sine 35 equals B sine 60. Now to solve for B, I just divide both sides by sine 60 and put it all in the calculator, and I'm done. Okay, same thing to find the side C. I'm just going to cross multiply and solve for C. Okay, so this will work if I know two angles and I have one side and I need another side. It will also work if I have two sides and I have one angle, as long as one of those sides is opposite the angle I have. Okay, let's see if I can come up with one where it won't work. If I wanted to solve this triangle, look at law of sines. Law of sines, I don't know this angle, and I don't know this angle, right? Law of sines would tell me I take sine of 35 over the side opposite but I don't have that side, is equal to this angle, the sine of this angle over 5. So I've got too many unknowns. So this is an example of a triangle I can't use the law of sines to solve. This is where law of cosines comes in. Okay, law of cosines, which is also up there, that's one of 3 variations. But they all mean, they're all the same. If I'm looking for the side A, and I have angle A, I would use this one. If I'm looking for side B, and I have angle B, then I would say B squared equals A squared plus C squared minus 2AC cosine B. It's the same equation. You're just going to interchange the side and angle that you have to solve it. Okay, so let me show you an example using this problem of how I might use law of cosines to solve this triangle. I can find the side opposite angle A because I know the side B, and I know the side C, and I know the angle A. So I have all of these variables here in the triangle. I already know the values. The only thing I don't know is what A is. And I can use this formula to solve for it. Okay, so I'll say A squared equals B squared is 25, C squared is 49, minus 2 times B times C, 5 times 7. See what I'm doing? I'm just filling in what I have. Cosine 35. So at this point, just plug all of this in your calculator in that order. Take the square root. And I can find A. Because A squared is equal to all of this. Okay? So if I use and find a calculator, all I'm going to do is plug in 25 plus 49, and then minus, and I just put everything in parentheses at this point, 2 times 5 times 7 cosine 35. And I get 16.66. Then I take the square root of that, and I know that now side A is 4.1 if I round to the 10th. And I got that using the law of cosines. Okay, now if I'm trying to solve this triangle, I'm still missing 2 angles. But I have this angle on the side opposite. So if I'm trying to find this angle, I can use the law of sines now. Because I can say sine 35 over 4.1 equals sine, I don't know, angle B. That's one of the 2 I'm missing. Over the side opposite angle B. Cross multiply. I get 5 sine 35 equals 4.1 sine B. Divide by 4.1. So I get sine B equals this whole thing, which I'll just plug in and round. 5 sine 35 divided by 4.1. About 0.699. I need the angle, right? What function do I do when I'm looking for the angle? Inverse sine. So to find the angle, I'm just going to take the inverse sine of this. So that angle is about 44.4 degrees. And now I know this angle, I can find this one by subtracting the sum by 180 from 180. Right? And I've just solved this triangle. And they only started me off with the angle and 2 sides. And I found the third side and the other 2 angles using law of cosines and then law of sines. Okay? So these 2 laws are laws that we can use to solve triangles that are not right triangles. The easiest of the 2 would be law of sines. So if you can use law of sines and you only have one missing piece, like we did here, I would recommend you use that. But a problem like this, we couldn't use law of sines because we had too many unknowns. So we had to start with law of cosines. Huh? No, it's just there's two laws, law of sine, law of cosines. That's it. These are the only two laws you need to know to solve any triangle. Okay, let me open up some big ideas for you, because I don't think I've done that yet. And then
I reloaded and I can't find
TK12.